Okay. So we just group is. I think I know what to do with that first. Okay. So the cosine function, it starts at 1, doesn't it? And then it goes down.
Yeah.
So it's been flipped.
Has it?
I think so, because it starts out on a down, doesn't it? It starts off at 1, and it's like the peak of it, and it goes down and crosses through 2, right?
Yeah.
Or pi 2.
I don't think it's been flipped. I think it's just been.
Might have just been stretched and moved.
That's what I was thinking. Stretched and then moved over.
So it would have, like the regular, the normal graph would have started at 1, and that would have been the peak, right? And then it would have gone down. So it would have been, I don't know, I kind of thought that it was like, so it was multiplied by 5, the cosine, so A would be 5.
Okay, yeah, that's what I was just looking at.
Okay.
And then it shifted over here. It'd be 5 cosine parentheses x minus, what is that?
It's 3 pi over 2?
Yeah,
Pi over 2.
That's what I'm thinking. That's what I'm seeing. Yep.
Does it stay negative or would it become a positive? I'm not sure how to do that. Like for the transformation.
It'd be a minus. Is that what you're looking at? Are you looking at?
It'd be minus 3 pi over 2. It'd be minus 3 pi over 2.
It's kind of the standard.
Okay, cool.
So
For going like left or right, I always think like minus, you usually go towards like the negative on a graph. And so you usually go that way, but you want to go the opposite way. So if it's positive, you want to go right, but you have to go left. It's like you just do the opposite of whatever the sign is. So that's a trick that I learned in high school.
I don't think A is 5 because if you look at the bottom waves don't go down to 5.
No, I'm talking for speed.
So it's
like x minus.
Would it be 3?
I'm talking about that part, yeah.
Yeah, so the amplitude has got to be 3. And then,
and then it's shifted up 4.
So
right? Or no, wait. No, it's not. Because you stretch it first.
Yeah, you stretch it with an amplitude 3, and then you push it up 2.
Okay, so if we start off with a graph, and then we have 1, and it's going to go. So first we stretch it by 3, so. Right?
Yep. And then has the period changed?
And then that's 4, so it's. Wait, that's not right.
B hasn't changed at all. the formula, I got y equals 3 cosine parentheses x minus 3 pi over 2 plus 2.
The only thing is when I plug that in the calculator, it doesn't match up. So it crosses as a y-intercept of 2, the equation that we made, instead of 0. Or just below 0 or whatever that is.
Yeah. I don't know why the calculator's making it like that. That's not how it should look.
So it is right?
Oh yeah, that's why I just can't understand why the calculator's making it look like that. That's what it told us.
Wait. I forgot about the period change. Did we forget about the period change?
Well, that's what I was wondering. If the period had changed at all, but
Yeah, it looks like it because normal period change is 2 pi.
So this is like 1.5. Because it goes from 0 to 3 pi.
Be like, the picture's so tiny.
yeah.
This period changes. Looks like period change is it's like 4 pi for it to repeat.
What is it?
I think it's 4 pi because if you look at pi over 2, that point, and then 5 pi over 2, that's like half of it. So it stands to reason that the other half is that far away from it. Like 2 pi. Does that make any sense?
Do you say 7 pi over 2 is halfway?
What?
So 7 pi over 2 is halfway? Or what?
Sorry, what?
Is it 7 pi over 2 that's halfway?
No, I was saying, I was just looking like, I don't know how to explain it. Like, say it was shifted, the point pi over 2 was shifted to 0, 2. I don't know how to explain this. Like half the cycle happens between pi over 2 and 5 pi over 2, right? And then it goes down and then comes back up. Can you see that?
Yeah.
Like half the wave is from pi over 2 to 5 pi over 2. So that length, if it was shifted to the 0, that would be 0 to 2 pi is the upper part. And then 2 pi to 4 pi would be the rest. I don't know if that makes any sense.
Oh boy. Three. So yeah, I think you are right with 4. So when you look at it, so if you shift it all back so it's regular again, the peak of the wave would be at 0, and then the bottom of the next wave is at I don't know, might not be at 3 pi over 2. That's confusing. Never mind.
Okay, like think of it this way. If this was a sine function, where would the 0, 0 point be right now in this graph? Where would it have gone?
It'd be pi over 2, 2.
Yeah. Okay. And then when does it hit the x-axis again? If pi over 2, 2, if 2 was the x-axis, where would it hit it again?
5 pi over 2.
Right. So that's half of the wave. That's what I'm saying.
Yeah.
So that half of the wave. So the other half is going to take the same amount of time. So that'll be to whatever that point is. But if it was shifted from pi over 2 to 0 for the x coordinate, then like here, if you've got like if you got this, right? That's kind of like our graph, right? If you shifted it back like that, if this is 5 pi over 2, and this is 2 pi, you see what I'm saying? Then half of the wave is from 0 to 2 pi. So half of the wave. So the whole wave is going to be 4 pi. Right? Does that make sense?
I think so.
Michael, you look confused.
I'm just trying to work it out on the paper.
So I think if we know that the period change is 4 pi, then period change is 2 pi over b. In this case, you want – so the formula is x equals 2 pi over b, right, to get the period change? So you want x to be 4 pi. So what do you divide 2 pi by to get 4 pi?
0.5.
Yep.
Okay.
I think we had everything else right. I think it's y equals 3 cosine 1/2 times x minus 3 pi over 2 plus 2.
The only thing is, it's the plus 2 that's killing us, because when you plug it into the calculator, you're just going to get a 2 intercept.
Try plugging this in. Try plugging this in.
Let me see. Yeah, that's what I got plugged in.
That's what you plugged in and it didn't look right?
No. Here, I'll send you a screenshot of what it looks like so you can see what I'm talking about. 1 second. Maybe we can figure it out. All right, just send in the group text.
Read up. That's not what I got.
So you got to change the parentheses so it's 1/2 parentheses x plus, or x minus 3 pi over 2 parentheses.
Let me try that.
You have x plus on that one.
Okay.
So 3 cosine parentheses 1/2 parentheses x minus 3 pi over 2 parentheses plus 2.
Okay. Yeah, I got it. It's working.
Okay.
Yeah, it matches exactly up with the other one. So
Perfect. Who's printing this sucker off and doing the notes?
I can turn in the group quiz.
Okay, perfect.
Let me just write this down real quick.
So we agreed.
I believe so.
So y equals 3 times the cosine, parentheses 1/2, parentheses x minus 3 pi over 2, parentheses plus 2.
Yep.
We also have to state the range. So the range is -1 to 5.
Yeah. Domain is all real numbers. Do we have to say the domain?
It just
Yeah,
all
direct domain is all real numbers. But so
It's
you want these in brackets, not parentheses, right? For the domain.
Yeah.
For the range, I mean.
Yep.
Yeah, the range is in brackets.
Okay, number 2, find the sine of alpha, given that the cosine of alpha equals 2/5 and sine of alpha is less than 0. So sine squared of alpha plus cosine squared of alpha equals 1 is the formula.
Okay. Right.
Wait, what was that again?
So number 2, we'll use the formula sine squared of alpha plus cosine squared of alpha equals 1.
Gotcha.
So you got 4 over 25 plus y squared equals 1. Y squared equals, what's that, 21 over 25?
Yeah. So plus or minus square root of 21 over 25 equals sine of, and it's less than 0, so we know that it's
Negative.
going to be negative square root of 21 over 5.
Yep.
Everybody get that?
Yeah.
No, can you show me the work that you did for that? Because I got the root 21 over 5, but I didn't get negative. So
it's
when
plus or minus. Yeah.
You have plus or minus, but then the problem also tells us that the sine of A is less than 0. So you can rule out the positive.
Okay.
You're just left with the negative root.
Okay. Because I did it before, like the group chat, and this is how I did it because I didn't use a formula. So maybe I just did it wrong or something, but I just did like the Pythagorean theorem, and that's how I got it.
Let's see.
So you got x equals the root of 21, square root of 21.
Over 5, yep.
So yeah, when you did that, you had x squared equals 21, and then you did the square root. It's got to be plus or minus.
Okay.
Because every single time you square root something, there's going to be possibility of plus and minus.
Right.
Square root just any equation in algebra.
So how do you know it's a minus in this situation though?
Where it says it's less than 0. And
Oh, okay.
so, yeah, given that cosine alpha equals 2 over 5 and sine of alpha is less than 0.
So how did you guys like do it in the formula? Like, could I see like the?
Here, I'll take a picture.
Okay, cool. I'm just confused on
So
how to
it's
use
like-
the formula.
Just y squared plus x squared equals 1. And
Okay.
sine is equal to y and cosine is equal to x. You just plug in 2/5 squared plus y squared equals 1. And you just solve it for y.
My phone's being really slow, sorry.
That's cool.
Okay. How long have you been in there for?
Oh, like 3 minutes. Yeah.
So messed up.
Oops. There. It's sending or something
Cool.
sideways. Oh, it's sending. I didn't write down all the work, but so you have the formula sine of alpha squared plus cosine of alpha squared equals 1. You know the cosine of alpha is 2/5, so square that. You get 4/25. The sine of alpha squared equals 1. So then 25 over 25 minus 4 over 25 is 21 over 25.
Okay.
And then you take the positive and negative square root of that. We know it's less than 0, so it's the negative root. So negative root of 21 over 5. That help at all?
Yeah. So, yeah, I got it now. Okay, sweet.
Okay.
I
Number
don't understand
3.
number 3.
Use a fundamental identity to write 2 functions for cosine of A or cosine of alpha and items. What?
I don't know.
The fundamental identity formula is the one we just used. I know that.
So you just write like cosine equals.
But what does in items of sine of alpha mean? In items? What does that mean?
I have no freaking clue.
Would this be kind of like GHOA, where it's like the opposite over hypotenuse or whatever and that type deal?
No clue. I just don't understand what in items of sine means.
So let's see. Fundamental identity is the thing we just used. You said, right?
Yeah.
Okay. Let's see. Equals 1. Maybe she meant in terms of,
That's what I'm thinking.
I mean, it wouldn't be the first time that she wrote something wrong on the homework or the quiz. So that would be, I guess you could say like sine squared A equals 1 minus cosine squared A. And then you could also say, I guess, sine A equals the square root of 1 minus cosine squared A, right? For a given value of,
Oh, you said sine squared of alpha equals 1 minus sine squared of alpha, or sine squared of alpha equals plus or minus the root of 1 minus sine of alpha,
yeah,
or sine squared of alpha.
yeah, that's what I was thinking.
That's the only thing I can think of.
And what does it mean? Indicate which formula to use for a given value of alpha. Well, you could only use the or no, I guess you could use both of them if it's like how in the problem before it could only be a negative. I was thinking maybe that would mean you could only use the second formula that we came up with, but I guess you could use both of them still.
But maybe like for certain alphas, it'd be better to use one formula over the other. Maybe that's what she means.
Yeah. So how would we know which? Huh.
Either one.
Yeah, I don't get it.
Uh-oh. It's probably somewhere in the reading, but I never read.
Same. Well, I guess if so if we have sine squared alpha equals 1 minus cosine squared alpha, then for that one, you'd really only want to use a positive, right? Because if you use a negative, then you could still get the same answer, I guess, because you're squaring it. I don't know.
Wait.
Yeah, so you never want to have a negative or a square of a negative number, right?
Yeah.
Then it just becomes a whatchamacallit, not real solution, whatever you want to call that.
Yeah. So we could say, but that's the thing though, like you're just eventually going to end up taking the square root of both sides, even if you use the first one. So that's what I don't get.
That's confusing.
Written in terms of the sine of alpha, wouldn't it be sine of alpha squared plus 1 minus the sine of alpha squared equals 1? Because the cosine of alpha squared is 1 minus the sine of alpha squared. You know what I mean? So I took the identity formula and I solved for the cosine of alpha squared. And plugged that back into the original equation. So sine of alpha squared plus 1 minus the sine of alpha squared equals 1. But I can't think of another formula. And I don't even know if that's right. Guess you could do.
Oh.
Man.
Okay, the minimum with this, if you're solving for the cosine of alpha squared from the original equation, then the cosine of alpha equals plus or minus the square root of 1 minus the sine of alpha squared. And then plug that back in. So it's sine squared of alpha plus or minus the square root of 1 minus the sine squared of alpha equals 1. I don't know. And that could be turned into two equations, I guess, plus or minus. And then if alpha is... This is just a very regularly written question.
Seriously?
Yeah, I don't understand it.
Hmm. I'm gonna text the TA and see if she can meet today at all. I have no idea how to do this question. Like, I mean, I'm not even sure what it's asking for.
Yeah. Funky business, man.
Can you think of anything, Julia?
I was kind of doing what you were doing. So I got like close to the same thing. I think I just did a mistake, so I'm just trying to find the mistake. Because I bet you I made a mistake. But I kind of did what you did.
And then plugged it into the original equation.
Yeah.
I'm just wondering if there's a way to. No. I think that's good. I was gonna say I was wondering if there's a way to solve for just alpha, not the cosine of alpha, but I don't think there is. And you don't want just alpha; you want it
Want sine
written
of
in.
alpha. Cosine of alpha.
What?
You want like the cosine of alpha, because it's like it's not alpha's not a
Yeah.
number.
Yeah.
Okay, so she said she can meet at 2:15 today, but yeah, I don't know how to.
Well, how about we send you the work we did
Okay.
with solving for the cosine of alpha, and then just ask her if we were in the right direction, maybe?
Okay.
You think that would be too bad?
Yeah, I think that'd be good. Because yeah, like I said, the question's just worded really weird. So
Yeah.
I mean, worst case, she just says like, I can't help you since it's like a quiz. But last time when we had problems with the quiz, she said she could help and she did. So I'm sure she will.
Yeah, and if we need to, I mean, we can meet again for a couple minutes.
Yeah, for sure.
Like, I have to go to Pocatello today, but I mean, I can meet on my phone. It's not a problem.
You know, why you guys just send me the work? I can meet with her at 2:30, and then I can just like screenshot the work that we did when I was with her, and then send that to you guys so you know how to solve it and like what they're asking for.
Yeah, that sounds good. 'Cause I had no idea.
Okay, and then I can turn in that group quiz.
Okay.
Cool. So let me just. All right.
The
So
other two questions weren't too bad, but we just don't understand what's going on with this other one. So
yeah. Yeah. So I'll send you guys a screenshot of the work that I do with her too, so you guys know.
okay.
Cool. So is there anything else you guys want to go over, or is that it? Just the group quiz, right?
No.
Okay. Oh man.
Well, that was fun.
So here.
So you're gonna turn in the video, Caleb?
Yeah.
Okay, cool.
Tell me if you think this you can just show this to her and ask her if we were like headed in the right direction, I guess.
Okay, cool.
Tell me if you think that looks right.
All right, I'll leave now.
There you go. Just
All right, let's see. Yeah, to me, that's the only thing that makes sense, like, is what you did, so. Like, if she says something else, I'll let you know, but that's the only thing I can even think of,
Yeah.
so. Yeah, I'll let you guys know.
All right.
Cool.
Cool.
And that's exactly what I did. So my work is the same thing as Curtis's.
Yeah.
Okay, cool.
I didn't know what to do, so now I know. So yeah.
Yeah, guys.
Cool.
Well, let us know how it goes, Michael.
Yeah, we'll do.
Adios.
Okay, talk to you guys later.
Bye.
Yeah.